Imagine if they're right. Planets like Earth, as common as dirt. Kinda changes everything, doesn't it? If that is what's in store, then exploring space in the future figures to be quite an adventure. Picture being able to leapfrog your way from near-Earth orbit to the Moon, to Mars, and then beyond, all the way to those Earth-like planets. The questions then are simple. How? When? And who gets to go?
All of us wonder what's out there in outer space.
When at last we said our final goodbyes to the 20th century, fewer than 400 people had experienced the thrill of space travel. Now, it's our turn.
50 years after the Wright brothers flew, we had regular transatlantic airplanes carrying you and me across the ocean taking vacations. 50 years from now, space travel will be available to the man in the street.
We're talking about not just millionaires and entrepreneurs and daredevils and astronauts. We're talking about school teachers. We're talking about children. We're talking about ordinary citizens having the capability of fulfilling the thrill of a lifetime, to soar into outer space.
This is one of the biggest changes coming. Space exploration that includes everybody. Why will it happen? 3 reasons, really. Number 1, we want to go.
People love to take adventures and see what's over the next mountain range. And space is our next mountain range. It's the only place we haven't gone.
We will be sending civilian tourists into space. That's guaranteed.
Number 2, we really don't have a choice.
In the future, our very survival may depend on whether or not we can explore outer space. It's very dangerous out there. There are comets, there are meteors. The Earth itself, the atmosphere could change and make life very difficult on the planet Earth. That's why this urge to explore will eventually save the human species from extinction.
But most of all, number 3, there is a lot of money to be made.
The future of space exploration and commercialization is going to change history more than anything else going back to the beginning of time.
I fundamentally believe that the first trillionaires are going to be made in space. Everything we hold of value here on the planet, minerals, metals, real estate, information, energy, is available in near infinite quantities in space.
It's not a matter of if, it's a matter of when. And I really think that now, with all the new companies we're seeing and the new initiatives, that the commercial aspects and the commercial economic incentives of space, space transportation, space development, space businesses are going to develop quickly, very quickly.
In fact, it's already begun. People see gold in them thar stars, and they're clamoring to get at it. Starting right here on Earth. Ever heard of Space Adventures? Space Adventures is a company bent on turning space into a vacation destination. Right now, for $5,400, you can board a Russian jet and grab a taste of weightlessness. Think of this as practice for the trip.
Floating higher and higher. A wonderful feeling.
It's absolutely a physical sensation you cannot reproduce. It's unbelievable.
But within 3 to 5 years, they hope to offer a suborbital space flight that will take us to the very edge of space. Price tag, $98,000, or roughly half the cost of buying a house. Now, there's just one catch. Space Adventures can't fly us anywhere until they have a spaceship.
To privately build a spaceship, privately finance that ship,
Enter Peter Diamandis and the International X Prize Foundation. Diamandis established the X Prize in 1996 for the sole purpose of getting people to develop new concepts in launch vehicles that can carry paying passengers. A big cash award will go to the first team to fly a spaceship with 3 adults to 100 kilometers, land, and then make the trip again within 2 weeks.
When someone does that, they'll get a $10 million check.
Life is a daring adventure or nothing. Helen Keller.
Now, instead of waiting around for NASA, 17 companies from 5 countries are determined to beat the space agency at its own game and build a new generation of hardware.
The hope and the expectation is that through this competition, we'll be able to generate not one, but maybe a dozen different designs specifically put together to carry you and I into space as tourists.
Concepts range from sea-launched rockets and spacecraft that grab a tow to get off the ground to the Roton rocket that lands like a helicopter. So can we expect that in the next couple of years we'll be getting our boarding passes? Well, I wouldn't count on it, because the X Prize contenders have run into a very big problem: money. Spaceships are expensive to develop, and even more expensive to get off the ground.
Imagine John Glenn made out of solid gold. And then you understand the cost of what it took to send John Glenn into outer space. $10,000 per pound to put anything in orbit.
Turns out we won't get far until the cost of space travel comes down, way down.
I truly believe that the key to opening this up is going to be tourism. The one thing that tourism has, which all the other space markets doesn't have, is volume. There are millions of self-loading carbon payloads, namely you and I, who've got money to go into space, and that will make all the difference.
Within the next 5 to 10 years, a new generation of spacecraft should reduce the cost of space travel by a factor of 10 and eventually a factor of 100. So going into outer space may be no more expensive than a safari in Africa.
Which brings us back to NASA. NASA might just win this race yet, because engineers there already have cost-cutting concepts in the works.
Today, booster rockets are very expensive, and they take 3 stages to go into orbit.
New NASA designs for the near future promise single-stage-to-orbit vehicles, completely reusable craft that fly into space and return like an airplane without dropping any parts. The next hurdle is to replace conventional propulsion.
The key is going to be getting away from chemical propulsion. Chemical propulsion has served us well, but you can't go very fast, and it takes a lot of fuel to get up to high velocities to make trip time shorter, and it's also expensive to launch all that fuel into space.
Just what will power the spaceships of our future? Well, it all depends on where you want to go. For example, for short trips close to home, think magnets. A concept now in the works takes its cue from new high-speed maglev trains. It's a magnetic-powered concept called the magnetic levitation catapult, which means your ship gets hurled into space very, very fast.
We could actually levitate the craft and push it to near Mach 1 before it even leaves the ground. And so all that propulsion system that we now carry all the way to orbit can be left on the ground. It's easier to maintain, and the vehicle becomes smaller and looks more like an aircraft.
So, is it now just a matter of time until we hop aboard a spaceship to the nearest Earth orbit? Maybe not, because in order to get to the future, we first have to prepare ourselves. The next question you gotta ask yourself then is, how strong is your stomach? The work has begun. Now the journey that will one day take us to those Earth-like planets seems inevitable. Just imagine gazing out at the vastness of space, floating in weightlessness, the euphoria, the wonder, the nausea.
If you or I were launched into space on a vehicle like the space shuttle, there are a few things that are likely to happen to us beyond the gee whiz, here I am, isn't this wonderful, I'm in space, and they're not all fun.
If it's our pioneering spirit that gets us into space, it will likely be a shot of Dramamine that keeps us there, because the trip, it turns out, might very well make us sick. Just ask the two people who already went. Yes, 2 civilians have already proved that you don't have to join the space program to take short jaunts into space. There was the British chemist Helen Sharman, who spent 6 days on the Mir space station in 1989. Believe it or not, she answered an ad on the radio. Astronaut wanted, no experience necessary. The trip was actually part of a scheme to re-energize the Soviet space program. To this day, Helen is the only woman who has ever gone into space just for the fun of it.
You have to make sure something's attached all the time, otherwise it floats off and you never find it again.
The second civilian actually got paid to go up to Mir, a reporter from Japanese television. Trouble was, instead of the usual everything's A-OK, Akiyama radioed his wife, "I am definitely not okay." It seems space did not agree with him at all. The TV reporter turned space traveler was ill for much of his 8 days in space. Akiyama struggled with dizziness, lost his appetite, and survived mostly on tea and crackers.
There's something called space motion sickness. The reason for it, we have come to learn after a lot of experiments in space, is pretty clear. It's a form of motion sickness very much akin to air sickness and seasickness. And it doesn't hit everybody, but it occurs to between 2/3 and 3/4 of all first-time flyers.
I just bent my knees and my stomach came up. I wasn't even feeling sick. The 3 of us have bags, and I put it to my mouth. I looked up and someone handed me a wipe to clean up, and when I wiped my mouth, pieces went floating off. Geez, I had to grab them and put them back in the bag.
Not fun. Nausea, sweating, headache. Maybe it can be pushed all the way to vomiting, and it's not really a good idea to vomit in space because the vomitus floats all over the place. It's a mess. It makes you very unpopular unless you got the bag up to your face in time.
Front and put your feet in the foot holders.
Dr. Conrad Wall, an MD who spent his whole life learning everything there is to know about eardrums, is studying what happens to our sense of balance in microgravity.
Well, its formal name is the Earth Horizontal Axis Rotator, but we like to call it the barbecue spit.
Dr. Wall is one of the people looking into countermeasures. In other words, ways to make the dizzying effects of life in space less nauseating.
Okay, Jason, are you all set in there?
All fine.
Okay, great. We're going to start the machine up now. Ready to roll, Dave?
Ready to roll.
Roll them.
Using the so-called barbecue spit here at the Massachusetts Eye and Ear Infirmary in Boston, Wall is monitoring what happens to the body's central nervous system when it gets tossed around like a piece of luggage, just as it would be on a ride in weightlessness.
We're stimulating the balance organs, and we're measuring a reflexive movement of the eyes in response to that motion. Keep counting.
By changing the pitch of the machine,
look at every stripe in front of you.
Dr. Wall can effectively alter gravity, as it were. Less pitch, less eye movement. More pitch, more eye movement. And more motion sickness.
Count out loud. And that gives us a sense of what's going to happen when there may not be gravity.
Creating gravity in space would solve everything. But short of that, countermeasures are still pretty limited. Shots similar to Dramamine help. So might practice. That Space Adventures ride could constitute practice. But the simplest countermeasure is to wait it out as your body adapts to weightlessness. Apparently, your body will eventually come to grips with the nausea on its own. For starters, though, Dr. Wall does offer this advice.
If we were going to space tomorrow, I would eat a light meal tonight, get a lot of rest, and be prepared to take it easy for a couple of days so that I could enjoy it.
Conquering the effects of weightlessness is only step one. Next, you have to fight the disorientation that comes from having no real up or down. In other words, the nausea could come back once you get out of your seat and start moving around. Welcome to three-dimensional space orientation.
This ceiling somehow seems like a floor, and the floor seems like a ceiling. And what was on the left is now on the right. You have a sense that you've gone somewhere, but there was no motion required to get there. And that at this moment of change, of reorientation, you can feel rather nauseous.
It's called neurovestibular adaptation. And what it means is you'll have to learn how to navigate without the clues your body is used to getting from gravity.
Here on Earth, we're pretty much always upright with respect to our visual surround. We have gravity holding us down, and we're always on our feet.
This virtual reality setup combats a real lost in space scenario.
The objective of the experiment here is to explore spatial memory in a simplified situation, but resembles the problem that an astronaut is faced with in the node of a space station.
The subject plays astronaut, practicing how to find his way out of a space station.
It's sort of like a bit like playing the card game Concentration, where you're laying cards down on the table and you have to remember which one's where, except here we play it in 3 dimensions. And also we'll effectively turn you around or rotate the room around you. So you have to really be pretty good about learning opposite pairs and learning what corners look like.
And in fact, after an average of just 1 hour, tests show most people get pretty good at the game, which would seem to indicate that all of us can ultimately learn to deal with space disorientation.
Without progress, deviation is not possible. Who said them?
We're speeding Frank Zappa, you know that.
Just kidding you.
Now that we know what to expect, where will we go? Well, our first stop might be the International Space Station or something just like it. And if so, we're likely to lounge around in a place like this. It's called Transhab, as in transit habitat. Transhab can be attached to things like the space station and then inflated. A prototype has already been tested in NASA's space simulator. Collapsed, it fits in the shuttle's cargo bay. Inflated, it has as much living space as a 1,500 square foot ranch home.
It's actually laid out architecturally to be friendly to the crew, to have distinctive areas where they can recreate, areas where they can exercise. It's the first place where they'll have those kind of options available to them because it's not as structured as all these aluminum modules.
Not only is it comfortable, the fabric walls shield the crew from cosmic debris, which is very dangerous stuff. Tests show the kind of damage a tiny particle traveling at orbital speeds of over 14,000 miles per hour can do.
And in this case, we took this little 1 centimeter particle and shot at this 1.5 inch thick piece of aluminum, and you can see the kind of damage that happens from a tiny little particle like that.
But as the particle goes through a layer of high-tech fabric, it disintegrates some. Then it goes through another layer and disintegrates some more until it's all just pooped out.
And so the shield has done its job. It stopped the particle and kept the crew safe.
One day, the Transhab concept will likely make its way into commercial use. But until then, there is an astonishing plan to build an island in space using parts the space shuttle throws away.
I think this is going to change history.
Gene Myers is an industrial engineer turned space entrepreneur. He's one of the people who recognized its commercial potential almost from the start. And ever since the space shuttle first got off the ground, he's wanted to build an actual vacation resort in space out of the shuttle's external fuel tanks. At 154 feet long, The fuel tanks are the largest single space component ever built.
People that see these external tanks up close for the first time are always amazed at the size of these things. Other people have said that the pictures of the external tank with people walking around it looks like ants walking around a watermelon.
Meyer's idea is very simple. Every time the shuttle flies, the tanks get dumped into the ocean. Instead, why not keep them in orbit and hook a bunch of them together? Rotating slowly, the huge wheel will simulate 1/3 Earth gravity, enough to keep us right side up.
We've picked the 1/3 gravity number because that people can still walk around and function normally under that condition. Water flows for the showers, you can grow plants for the food, you can do all of these things, whereas if you had 0 gravity, you couldn't do any of that stuff.
Gene says that the first big wheel, yes, the plan calls for several, could be in place within 6 or 7 years. Each wheel, made of a dozen or more external tanks, will hold 400 people in cruise ship-like conditions.
We're pricing this thing so that the first 2 or 3 years of operation, it will probably cost roughly $100,000 for a couple to go up there for a week. We think by the 6th year of operation, we can drop that down to $25,000.
At $25,000, the cost of space travel begins to sound almost reasonable. But what if I told you that another space entrepreneur has a plan that'll get us all the way to the moon? Who could refuse that?
I never think of the future. It comes soon enough. Albert Einstein.
Imagine our next stop in space is on the moon. And our host is David Gump. Now, Gump wants to take us there, and he'll do it with a robot. From inside this garage in Northern Virginia, Gump has hatched a company called Lunacorp and his own daring entrepreneurial plan. A plan to land a robot on the moon's pole and explore for lunar ice.
Our robot will land near one of the poles and do several months of live exploration that you can access via the web, on television, and at science centers.
Finding lunar ice is a very big deal, because where there's ice, there's water. And where there's water, there's lots of possibilities, which is why Lunacorp wants to get to the moon.
We're starting off with a single robot to go to the poles to look for water, but we're going to supplement that with a whole family of robots to do things like extract the water, to emplace telescopes for scientists, to be able to start building habitats for settlers. There's going to be a plethora of robots going off doing lots of cool things to get ready for real frontier settlement.
Water on the moon would not only mean we could grow crops, we could also make rocket fuel. And if we could make rocket fuel on the moon,
that means we can land there and refuel our spaceships and go deeper into the solar system at far less cost than if we had to haul all of our fuel up from the Earth.
A refueling station on the moon makes a trip to Mars or even further, remember we're still working up to finding those Earth-like planets, that much more feasible. Before that can happen, though, Gump has to get his robots to the moon. A new concept in the works at NASA could be the answer. They call it the tether. The idea is that to haul stuff around in space, why spend money on conventional fuel? Instead, sling it around like a yo-yo. A short-range version that could be used to carry cargo from a low-orbit transport vehicle to the space station, or even the moon, is the electromagnetic tether. Now here's how it works. A satellite reels out a long, thin wire. Electricity flows along that wire, making its own magnetic field. Now, that magnetic field interacts with the Earth's magnetic field.
And they push against each other, much like would happen if you picked up two bar magnets and took the north poles and tried to put them together, they push apart. Well, we're using that same kind of a force to push on our tether thanks to the Earth. And therefore, we don't have to use fuel or any kind of propellant to move.
And that means that maneuvering cargo like Gump's robots suddenly becomes very cheap.
Now that's significant because in the past you'd have to use chemical rockets to do this maneuvering. Again, taking hundreds of pounds of fuel at $7,000 to $10,000 a pound to get into space. And the beauty of an electrodynamic tether is that it's completely reusable, so your cost per mission can be dramatically lower.
Once his robots are on the moon, Gump can realize his dream of building a refueling station that can help us travel to Mars. But how will we get there? Mars is at least 35 million miles away. Thus, we need speed. This is the engine NASA engineers believe will deliver. This is the Vasimir engine, which is NASA's easy way of saying variable specific impulse magnetoplasma rocket. And what that means is it won't burn anything. It will eject plasma. A plasma is a super hot gas, so hot that it can only be contained within a powerful magnetic field.
Typically, a plasma is as hot as the interior of the sun, for example. Extremely hot. We're talking about millions of degrees in temperature. The fundamental advantage of a plasma rocket over a chemical rocket is based on its temperature, because the hotter things are, why the faster they will move. And the key in a rocket is you want to let the material come out of the exhaust as hot as you can, or as fast as you can.
The huge amounts of electrical energy needed to heat the plasma will be generated by nuclear reactors, which will make the plasma rocket capable of reaching 44 kilometers per second, 5 times as fast as the shuttle in orbit.
Unlike the chemical rockets that we use today, where you get a big push and then you really coast the rest of the way with no impulse on your body, these rockets are much more gentle. And however, their push is continuous, so the rocket is on all the time.
The net result of all that power is that a plasma rocket will get you to Mars in a fraction of the 18 months it would take with conventional rockets.
We can reduce the trip time to the order of 90 days, for example, or maybe even faster than that. And that is very good news for human space travel.
90 days is still a long time when you take into account everything you will have to do without. Truth about the future of space travel is that if you don't like camping, you won't like a prolonged stay in space. Common day-to-day experiences will become complicated procedures. Imagine, if you will, zero-G hygiene.
You have to get used to the idea that going to the bathroom may be a little bit more inconvenient than going to the bathroom on a jetliner. So you're going to have to get used to the idea, first of all, of drinking through tubes. Otherwise, your dinner will be literally in your face. You'll have to get used to the idea of having suction take care of bodily functions when you go to the bathroom.
Obviously, there's no sewer system and no city services along the way, or even once you arrive on Mars, which means you'll have to drink recycled sweat and urine. Call this the ick factor. NASA has built another space prototype that illustrates the ick factor, the Bioplex, a sort of space, an example of a closed-loop environmental system. Whoever is inside this atmospherically sealed chamber must recycle their own, well, you know. With an eye towards the future, NASA has already locked a crew of 4 people inside the Bioplex, what they affectionately call the can, for a mission, or was that a sentence, of 91 days. Eventually, they will confine one lucky crew for a year and a half.
During the 91-day test that Nigel was the commander of, we started that test with a little over 200 gallons of water, and we finished that test with about 200 gallons of water as well, but we processed 2,000 during the test. Through the crew. So we processed that water about 10 times. He drank the same water about 10 times, and he's living proof that it works.
Besides testing how to make the most out of limited air and water, the crew discovered what it may be like traveling to other planets without all the comforts of home.
You literally know everything about those people. There is no privacy in those chambers. There's no audible privacy. So you know how many times they go to the bathroom. You know how much they sweat when they exercise. So you really have to be very open with each other. You certainly need a sense of humor.
But what about being somewhere else, say on the surface of another planet? For example, Mars. That the can't do. So instead, we travel to Mars on Earth. The latest estimates say we will get to Mars in the year 2018. In historical terms, that's practically tomorrow, which is why preparation is already underway. Welcome to Devon Island, the closest thing to Mars on Earth. Miles above the Arctic Circle, where during the summer the sun never sets, a team of NASA-sponsored scientists camp on the shores of what was once an ancient sea.
Devon Island is an incredible place. It's the largest uninhabited island on our planet. It's about the size of West Virginia. And when you are there, you are the population of Devon Island. The best way to predict the future is to invent it. Alan Kay. Is that all right?
Yes, that's perfect.
This is NASA's rehearsal for your trip to Mars. The idea was to find a place so remote, so uninhabitable, so unearthly that it's like standing on the surface of another planet. And then send an expedition there to do a run-through.
In a case like this, an expedition to a world that's a cosmic ocean away, there are the devils in the details. You are planning the mother of all camping trips. This is an expedition that will last 2.5 years. If you forget something at home, there's no going back to go get it. You are on your way to Mars, and you better be prepared.
The average summer temperature on Devon Island is 40 degrees Celsius. On Mars, it's minus 70 degrees.
The environment outside is not just cold or unpleasant, it's lethal. It's a low-pressure atmosphere. It's equivalent of about 100,000 feet on the Earth in altitude. You get zapped by ultraviolet light intensely during the day. There's no liquid water really available outside. In fact, you have to drill to get to any ice, if it is there at all.
In this unearthly place that appears completely barren, NASA explorers aren't just looking for water, they're looking for signs of life and finding that it can flourish in the least likely places.
Wow, look at these. These are all green on the rocks. You can see the cyanobacteria here.
Oh, yeah.
You know, we should look at them under microscope also before we sequence them.
That's a good idea.
Just to see what they look like.
And I think we have one back at
Yep,
base camp.
I'll look at them in the lab.
If we're going to look for life on Mars, or at least dead life on Mars that might have been there 3 billion years ago in ancient Martian lakes, it's microbes like these that we have to try and look for, or at least their remains, to try and find evidence of past life on Mars.
Mars will be different, there's no question. But what we're gaining here is background, experience. By noticing, for example, where the hot springs are located in the crater, we can strategize as to how we might go about finding those same hot springs on Mars.
If scientists can unravel the life forms of Devon Island, this might tell us a lot about what sort of things could survive on Mars.
We hope to potentially one day engineer microorganisms to contain gene sequences such as those found here on Devon Island that we may perhaps one day take to Mars with us so that they can live there also.
If they can live there, chances are we can too. And if life can be found on Mars, it stands to reason we can find life elsewhere, say on the next leg of our journey into deep space. But for that, we're gonna need a whole other way of traveling. Think science fiction.
All of us have thrilled to see the Starship Enterprise race across the heavens. We've all seen the movie Star Wars, but hey, we're still many generations away from being able to field a genuine starship. However, within a 50-year time frame, I think scientists will seriously build prototypes that may send small packages out to the nearby stars.
The latest thinking says that the advanced propulsion systems that will take us into deep space won't even burn fuel.
Space isn't empty. There's a lot out there. There's sunlight. There's radiation that you can use for transportation. There are magnetic fields. There are plasma clouds around the Earth and around Jupiter. And if you can find a way, typically with large systems, to tap into this diffuse energy, and you don't have to carry it all with you, and you can potentially revolutionize the way we explore space.
For trips very far out into the solar system, NASA engineers are experimenting with wind, solar wind. Turns out there's enough of it that someday we might actually sail through space.
Solar sails really rely on strong, lightweight materials, such as what I hold in my hand. They work by virtue of sunlight reflecting off of material.
We can't feel it, but light does exert force, and out in space, that's enough force to move really lightweight things. The same way wind on Earth can propel a sailboat.
And since the sunlight is constant, even though it's very low pressure, if you have a large enough sail and you push on it long enough, it'll start moving very rapidly. And that's the key to a solar sail, in that you're not taking your fuel with you, and you've got this constant push from the sun that lets you get your propulsion.
If the solar sail concept takes off, it will likely be used first for robotic flights out of the solar system, which you may view as a blessing in disguise once you hear what these long-distance trips are likely to do to your body. And you thought the floating vomitus was bad.
The serious problems for the longer term in space are not with the inner ear or with the heart and the cardiovascular system, but with our bones and muscles.
Turns out weightlessness isn't just hard on your stomach. It's not so great for the rest of you either. Bones lose calcium, muscles weaken. A long trip, say anything over a month, will probably leave you, well, frail. Let's put it that way.
We lose about 0.5% of our body's bone mass every month. Well, for a 1 week or 2 week flight, that's not serious. But if you're talking about going up for many, many months or years, then we're going to find that our big weight-supporting bones are getting smaller and smaller, run the risk that if there is a fracture, it won't be able to re-heal.
The astronauts that were up on the American Skylab station found that their hearts shrunk by 10% while they were up there for 2 or 3 months because there was so little work for their hearts to do. When they came back, they used to get dizzy quite often because all of a sudden their heart had to pump 3 times as much.
The solution to all of this is right out of the movies, artificial gravity. A rotating spacecraft could replace gravity with centrifugal force.
It would work, but it's impractical. The cost and the complexity of having very, very large rotating space vehicles are probably unnecessary.
So instead, scientists are experimenting with small radius centrifuges, compact enough to be practical, big enough to exercise in.
We can have what I've referred to as a spin in the gym. And the spin in the gym might be all that's necessary to maintain body condition so that any of us could go up not just for short duration flights, but go up for flights of an indefinite period, weeks, months, years. and come back in a condition which is safe and healthy. If you like amusement parks, you like this ride.
The theory is that you lie on a spinning bed or something like it and do exercises, say crunches or leg lifts, for about 45 minutes a day. The gravity created by the spinning adds just enough force to the workout to keep your body from falling apart. Now, if that's all it takes, then what's stopping us from getting to those Earth-like planets? Less than you might expect.
You're going to have to feed me that first line. I wasn't kidding. It is difficult to say what is impossible, for the dream of yesterday is the hope of today and the reality of tomorrow. Robert Goddard.
We've finally reached the most ambitious part of our journey, interstellar space travel, the stuff of movies and magazines. Or is it? A concept that packs fantastic power in amazingly little space is on the horizon: antimatter annihilation.
Antimatter is the highest energy reaction that we know of in physics. Just to give you sort of an idea of the amount of energy, 1 raisin worth of antimatter in the form of antihydrogen, when reacted with normal matter, releases as much energy as that in 23 shuttle external tanks.
Call it raisins per launch. 23 shuttle launches equal the power of just 1 raisin's worth of antimatter. That's what will likely power our spaceships of the future. As far out as it sounds, the people at NASA's Marshall Space Flight Center in Alabama are actually figuring out ways to trap and store antimatter.
We won't be seeing this applied in the next 10 years, but the fundamental research to make that kind of technology work will be carried out over the next decade. It's not science fiction. Antimatter's been around for a long time. It's produced in particle accelerators, in research labs. The key is trapping enough of it long enough and being able to use it for propulsion.
It's kind of fun to do the impossible. Walt Disney.
Assuming they can get this antimatter idea to work, and why assume they won't, then we should be on our way to the farthest corners of space, in search of the Earth-like planets we've waited for. And chances are, we'll already know exactly where to look. NASA has another trick up its sleeve that, if successful, will point us directly to our final destination. It's a program called Origins.
Origins is the search for the origins of galaxies, the origins of stars, and most importantly, the origins of solar systems and planets.
And the 2 big questions they intend to answer are, where do we come from, and are we alone? How? With a new generation of orbiting telescopes that will look deeper into the universe than ever before. Think Super Hubble.
The next big one up is Next Generation Space Telescope, and this is a huge leap forward in technology. It's an 8-meter mirror, about 4 times the size of the Hubble Space Telescope.
The Next Generation Space Telescope, or NGST, is scheduled to go to work in the near future by 2010.
Bigger means that you can collect more photons so that you can see things farther away. And so NGST will look for very distant galaxies. And one of the things that it hopes to find is the first galaxies. The most beautiful thing we can experience is the mysterious. Albert Einstein. Sorry.
To find smaller, fainter, more distant objects, the telescopes will get bigger and ultimately will be linked together.
The sequence is that first you build something large like Next Generation Space Telescope. And then you put that thing in an array of telescopes. So first you start with something large, and then you array them up into an interferometer, and then you make something even bigger, and then you do an array of 30-meter telescopes.
But to answer the really big question, are we alone, means finding not just distant stars, but those planets like Earth, the ones that are going to be as common as dirt. And that's the job of a super space telescope called TPF, the Terrestrial Planet Finder. As fantastic as it sounds, NASA scientists actually believe Earth-like planets could be found within 15 years. Then comes the really exciting part.
The next event that's going to get the kind of excitement that Sputnik and Apollo had is going to be hard evidence for life outside of Earth. There is life outside of Earth. I'm absolutely convinced of it. I don't mean extraterrestrials. I don't mean people I don't like characters. But I mean evidence of life, either past or present. And that is going to excite the imagination of everybody here on Earth in a way which is at least as exciting as the dawn of the space age.
I think intelligent life is going to be very rare, but I think life itself is going to be ubiquitous. I think that we are going to find life everywhere. Everywhere where there's a shelf or a rock that it can live under, you know, anything, anywhere, we're going to find it. That's my guess. It's just going to be everywhere, but it's not going to be very advanced life. It is that people who speak or squawk or grunt or whatever are going to be really rare.
Finding life on another planet was, is, and will always be the ultimate goal. And when that day finally comes, the dream, the fantasy, call it what you want, will be realized. But what will matter most, the discovery or the reaction to it? It could be that the greatest change in the future will be within ourselves.
The discovery of extraterrestrial life is going to change everything around us. The definition of who we are, even our mythologies, even our religion and theology will be turned upside down if we encounter extraterrestrial intelligence or extraterrestrial life.